And then you have to add those. Then you have to add what changes because of acceleration. And the other one is just basically memorization. It's the squared ones. So you have v final squared equals v initial squared. It's 2a change in x.
Okay. So we have we want because we don't know final velocity of x or initial velocity of x, so we can't use the first one.
Nope.
The second one, that's position, right? X final.
Mm-hmm.
We know that. We know x initial. We don't know velocity initial. We do know time. And we do
Oh, wait. We forgot to write that over here, right?
Yeah, we don't know that time.
So we don't technically know this time, because it's talking about the time that you span during that time.
Okay. So that would be if it was Tx or Ty? Or T initial and T final?
Yeah, so t doesn't have an x or y component, right?
Mm-hmm.
It's just time. It changes with both of them. So that's why you can use them to link them together, which is really beneficial, it turns out. So when you see this t in here, it'd be better expressed as delta t.
Oh, okay.
Because it's not one of these or the other. It would actually be, so this is t final, this is t initial. This t is actually t final minus t initial.
Okay.
Or delta t.
Okay. All right. Well, we don't know t. We can't use the last one either though, because it is almost the same as the first one. Because it has both velocity final and velocity initial, which we don't know either of those either.
Okay.
So we have to use the middle one, right?
Yes. Maybe. I don't know. Do we? So our problem with this one is we don't know time.
Mm-hmm. Okay, so then we quit.
Yeah. That's probably the best way to get into a grade in physics. What can we do to find time?
I don't know. Is there another formula for time?
Well, we've kind of exhausted, right? We've basically found out, well, we can't just find it with just our x.
Mm-hmm.
So what other information do we know?
About time?
Well, just in general. All our x information isn't doing us any good.
So go to y?
Yeah. Because the time here is the same for x and y.
Mm-hmm.
The time will always be the same.
Yeah.
So if you can solve for how long it takes for the time to y, then you can plug that back into your x equation.
Okay. So we would use the same equation with y?
Yeah, so you can think of these, the exact same equations, but with y's in there.
Okay.
All you have to remember is if you're going to use y final, you have to use y initial, and you have to use the velocity in y. You have to use the acceleration in y.
Okay. So y final, y initial, velocity initial in y, acceleration in y. Wow, we have everything in that one. That's cool.
Yeah, except for time, which is what we're solving.
Yeah.
So try that.
Okay. So our y final is 0. And then our y initial is 4 plus velocity initial 0 times time, we don't know that one though, but it's times by 0 anyways. Plus 1/2 times negative 9.8 times time squared. So this is exciting.
It should be. It's physics. It's fun, right?
It's fun when you understand.
Oh, yeah.
Okay, so then it's 9.8 over 2. I don't know what that is.
Let's say it's 4.9. Is that okay?
That sounds good. So that's negative 4.9. So 4 minus, wait, yeah, that's right. You can't do that though. I think the minus the 4 and negative 4 on one side and then divide by the 4.9, right?
Yeah.
Divide by 2 squared. Negative 4 divided by 4.9. That's a fun number.
Yeah, I don't know that one.
Calculator. 4 divided by 4.9 is 0.816. Which equals t squared, so I have to do square root of that. And that's 0.90.
So T equals 0.90.
Fun.
So where does that go?
That goes in T final.
Perfect. 0.90 seconds.
In seconds, okay. Okay, so now we have everything we need for the x equation to find the x initial velocity, right?
Yep.
Yes, so we can just plug it in now.
So, which one are we using?
The middle one.
Okay.
So x final is 25. 5 equals x initial 0 plus velocity initial of x. We don't know. Times time, which is 0.9 plus 1/2 a0, so that whole thing becomes 0.
Great. That's the best part.
Yeah, it is. Okay, so then we minus the 0 and divide by the 0.9.
Yep.
What did I do there? Did you do it in your head?
No.
Okay, good. 27.7.
What are the units?
It's going to be meters per second.
Yep.
Yes.
If you want to know something kind of cool, so when you get answers at the end, you kind of want to like check them against reality to see if it makes sense. We don't use meters per second for hardly anything in America, so we have a hard time just like thinking about what that means. But if you multiply it by 2, that number is approximately what that would be in miles per hour.
Okay.
So if you multiply this by 2, it's about 55. So this guy is pitching at 55 miles an hour, which is
That
totally,
makes sense, right?
Yeah, it's totally reasonable. Well, like Major League Baseball players would pitch at like 90, 95. So your friend, I mean, he's no Major League Baseball pitcher, is he?
No.
Yeah, he'd be throwing it
Obviously
50
not.
meters. Yeah, clearly. He'd never make it in the big leagues. So yeah, you can do that. That was what I did all the time, and I still do it, just to check my answers against reality. If you ended up with like a 300 meters per second,
Yeah.
you're like, well, I don't really know what meters per second means. Just multiply by 2, and you're like, I don't think he's pitching 600 miles an hour.
Yeah, that's true, that makes sense.
A little too fast.